Hello engineers, welcome back to Engineering Design Simplified. In this video series, I will be solving tough engineering mechanics problems. If you want to watch more videos like this, please subscribe to my channel and press that bell button so that you will be notified when I upload a new video. Today's problem is two rollers of weights P and Q are connected by a flexible string DE and rests on two mutually perpendicular planes AB and BC as shown in figure. Find the tension S in the string and the angle psi that it makes with the horizontal when the system is in equilibrium, where P equal to 60 lb and Q equal to 100 lb and alpha is 30 degrees. Assume that the string is inextensible and passes freely through slots in the smooth inclined planes AB and BC. So in this figure there are two mutually perpendicular planes AB and BC, and angle between horizontal and this plane is 60 degrees. Two rollers are connected by an inextensible string DE. So we need to find in this problem the tension in this string DE and angle of this string from the horizontal, that is psi. Let us see in the coming slides how to solve this problem analytically. The figure is redrawn here. So angle between AB and BC is 90 degrees given, and this angle is 60 degrees, that is also given. So if this is 60, this is 90, then this alpha will be 30 degrees. So let us see free body diagram of this roller. So this roller will have its own weight acting downwards, that is P is acting downwards, and a reaction RD perpendicular to this plane is going to act like this, and angle between horizontal and this RD will be 30 degrees since this is 30 degrees, and a tension in DE will be acting towards this, and we need to find here S and angle between S and horizontal. So let us transfer these forces and reactions onto XY plane. On XY plane we have S acting towards this direction, angle between horizontal and S is psi. RD is acting towards this direction, angle between horizontal and RD is 30 degrees, and P weight is acting perpendicularly downwards. Now let us resolve all these forces and reactions along X and Y direction. Along X direction, sigma Fx equal to 0, that is sum of forces along X direction equal to 0. So along X direction we have S cos psi, that is the horizontal component of S, equal to RD cos 30, that is horizontal component of RD cos 30. So let us call that equation 1. Here P is vertically downwards, so P does not have any horizontal component. So now let us write sigma Fy equal to 0, that is sum of forces along vertical along Y direction equal to 0. So along Y direction we have P is acting downwards vertically, that is equal to S sin psi, that is vertical component of S is S sin psi, plus RD sin 30, the vertical component of RD is RD sin 30. So let us call that equation 2. Now let us see free body diagram of this roller. So this roller will experience its own weight Q acting downwards, that is shown here, and RC, the reaction of this plane BC on this roller, will be acting towards this direction, that is perpendicular to this plane, and tension in this string will be acting towards this direction. Angle between S and horizontal will be psi again. So since this angle is 60 degrees and this is 30 degrees and RC is acting perpendicular to this plane, so angle between RC and horizontal will be 60 degrees. Now let us transfer all these forces and reactions onto XY plane. So on XY plane we have Q is acting downwards vertically and RC is acting towards this direction. Angle between RC and horizontal is 60 degrees. Similarly S is acting towards this direction and angle between horizontal and S is psi. So now let us resolve forces along X and Y direction. Along X direction sigma Fx equal to 0. So the horizontal component of S is S cos psi, that is acting towards this direction, that equal to RC cos 60, that is this length. So horizontal component of RC is RC cos 60. So let us call that equation 3. Now let us resolve along y direction. Along y direction we have Q is acting downwards equal to that is vertical component of S is S sin psi, that will be downwards, so we have put negative here, plus RC, the vertical component of RC is upwards and it is RC sin 60. Let us call that equation 4. Now let us see equations 1 and 3. So we have from equations 1 and 3 S cos psi equal to RD cos 30, S cos psi equal to RC cos 60. So let us equate equation 1 to equation 3. We get RD cos 30 equal to RC cos 60. So let us pull RD out. So we get RD equal to RC cos 60 by cos 30. Let us substitute this RD value in equation 2. So we get P equal to S sin psi plus RC cos 60 by cos 30 into sin 30. Sin 30 by cos 30, let us write that tan 30. So we get P equal to S sin psi plus RC cos 60 tan 30. Let us call that equation 5. Now let us add equation 4 and 5. So we get 5 we have written in the top and 4 in the bottom. So here this S sin psi and minus S sin psi will get cancelled. So we get P plus Q equal to RC into cos 60 tan 30 plus sin 60. So P is given 60 and Q is given 100. So P plus Q is 160. So we get, after simplification of this term, we get RC into 1.15. So RC equal to 160 by 1.15. So RC equal to 139.1 lb. Let us substitute this in RD. So RD equal to RC cos 60 by cos 30. So here we have substituted 139.1 for RC. So we get, after simplification RD equal to 80.31 lb. So far we have calculated RD and RC, the reactions. Now let us find psi and S. So let us divide equation 2 by equation 1. We get S sin psi is pulled towards this direction and P is moved to this side. So we get S sin psi by S cos psi equal to P minus RD sin 30 by RD cos 30. So this term S and S will get cancelled. So sin psi by cos psi will become tan psi. So P minus tan psi equal to P minus RD sin 30 by RD cos 30. So we have found RD in the previous slide. After substituting P, RD and simplification, we get tan psi equal to 0.49. So psi equal to tan inverse 0.49, that is 15.93, that is almost equal to 16 degrees. So we have found the psi, that is 16 degrees. From equation 1, that is S cos psi equal to RD cos 30. So after substituting all the known values and simplification, we get S equal to 72.33, that is almost equal to 72 lb. So in this problem we have found S, tension in the string, that is 72 lb, and psi, the angle between horizontal and the string, is 16 degrees, that we have found in the previous slide. That's all for today's video. If you like this content, please like, share and subscribe. Thanks for watching.